Hey guys, and welcome to a video looking at long multiplication. So long multiplication is an extension of what we've already been looking at with addition and subtraction, but now we're doing a different operation and we've got some different things that we need to keep in mind. So if we look at our first question, 18 times 3. So this is how we put it in an algorithm. Again, lining up via place value columns. Super important. Your place value knowledge is going to be key over the next little while. So first thing we do is we go 3 times the 8. We don't go 3 times the whole of 18. We just go 3 times 8 and we use our basic facts knowledge. So 3 times 8 is 24. So we write the 4 down, and similar to what we do with long addition, we put the 2 up there. Now, some of you would be thinking about long addition. You'd be thinking logically we're just going to add it straight away. No. Next thing you do is you go 3 times 1, which is 3, and then you add the 2, which is 5. Okay, so it's important that we follow the correct steps. Let's then look at the next problem, 14 times 5. So same deal again. We start with the 5 and we have to multiply both parts of the 14. So 5 times 4 is 20. So we put the 0 down and we carry the 2. 5 times 1 is our next step. 5 times 1 is 5. We then add the 2 that was left over from the previous bit. So 5 plus 2 is 7. So far, pretty straightforward. Okay. Now that is what's happening when you're getting a double digit and a single digit. When you get 2 double digit numbers, it gets a little bit more tricky because what we have to do is we have to make sure that the 1 multiplies the 2 and the 7, and the 3 multiplies the 2 and the 7. Okay, so there's a lot of stuff going on. So it's important we are paying attention and we really think this through. So first of all, let's just imagine the 3 isn't there and do everything we normally would without the 3 being there. 7 times 1, 7. 1 times 2, 2. Really straightforward. Now, it's important to remember with our place value knowledge what the 3 actually is. The 3 actually means 30. So we are timesing 7 by 30, and we're timesing 20 by 30. So it's important that we actually account for that in our equation. And to do that, we put a 0 in there every time we start on a new line. And that's what happens when you move on to the other digit. You start a new line. And this 0 is called a placeholder. Okay? And that's just reminding us we're now multiplying in the tens column. So we put 1 0 to represent the fact that it's in the tens. So 3 times 7, we then go into our problem, is 21. So we put the 1 down, we carry the 2. 3 times 2 is 6, plus 2 is 8. Okay, we've now done all our multiplication. We get given 2 numbers here. We don't just leave those 2 numbers. We then add our 2 parts of the answer together. So 7 plus 0, 7, 2 plus 1, 3, 8 plus nothing, 8. We get the answer 837. Okay. Now we're going to have a go at what is a bit more tricky and to see how this all works. We get 109 times 173. Okay, we follow the exact same procedure, but there'll be an extra step in. So 3 times 9, 7, 3, and we carry the 2. 3 times 0, 0, plus 2, 2. 3 times 1, 3. Okay, we put our placeholder because we're now moving into the tens column. We cross out the 2s, we use it. 7 times 9. 63. So we put a 3 down, carry the 6. 7 times 0, nothing, plus 6. Put the 6 down, and then 7 times 1, 7. Okay, we then move into the hundreds column. And when we do that, we then have to put 2 placeholders. 1 times 9, 9, 1 times 0, 0, 1 times 1, 1. That 6 had been crossed out. So we then get that, and then it's just a 3 stack addition problem. So this was a 7. I'll redo that for us. 7 plus 2 zeros are still going to be 7. 2 plus 3 plus 0, 5. 3 plus 6 plus 9, 18. So we carry our 1. 1 plus 7 plus 0, 8. And 1 plus nothing, 1. And that is our answer. Thank you for watching, gentlemen. And next time we'll be looking at